This video will be going over homework questions 4-36 to 4-41. The first one is going to refer back to the math notes box on this section, so please look back at that before you try to answer this. Miss Hong's class conducted an experiment by rolling a marble down different length slated boards and timing how long it took. The results are shown below. Describe the association. So we're trying to describe the association. That's the part that's in the math notes box in this lesson. So go back and take a look at that. So we're going to describe what is going on here in terms of the data points. And so what we're looking for is it linear? Is it non-linear? Is it a positive? Is it strong, weak? What are we looking for there? So looking at what's going on here, it does somewhat look linear right here, but it starts down at 0, 0. So then it almost has more of a curve there. So it does seem to appear to be non-linear. It also appears to be strong and going up or increasing in the positive direction. And there doesn't seem to be any outliers in this one. So we're going to say it's a very strong positive non-linear association. So once again, a very strong positive non-linear association. On question 37, there's 4 questions. We're just going back and solving each equation. So on the first one, A, we have 8A plus 1A or A minus 3 is equal to 6A minus 2A minus 3. So we're going to combine our like terms on each side. Then we're going to get the variable on one side. In this case, we'll subtract the 4a from both sides to get 5a minus 3 is equal to negative 3. Then we'll get the constant on the other side, so we're going to add 3. And then now we need to divide by 5. So a is equal to 0. And if we plug 0 back in to the original a values, you will see that if we have 8 times 0 plus 0 minus 3 should be equivalent to 6 times 0 minus 2 times 0 minus 3. So really everything cancels out except for the negative 3 on the left and the negative 3 on the right. On B, we have 2 binomials that are being multiplied. I'm going to use the distributive property. If you want to use your generic rectangles, you definitely can. So this would be m squared plus 3m plus 2m plus 6. So I'm using the distributive property. Distribute the m to the m and the 3, and then the 2 to the m and the 3. And then on the right side, I would have m squared minus 2m plus 2m minus 4. Once again, distributing the m to the m and the negative 2 and the 2 to the m and the negative 2. I will now combine my like terms. So I have m squared plus 5m plus 6 on the left, and m squared and the 2m and the negative 2m cancel. So that leaves me with only 2 terms on the right. We then want to cancel out the m squareds. So that'll just leave us with 5m plus 6 equals negative 4. We're able to subtract 6 to both sides and then divide by 5. And m is equal to negative 2. So if we plug this into the original, that would be negative 2 plus 2 times negative 2 plus 3 is equal to negative 2 plus 2 and negative 2 minus 2. So it looks like we'll get 0 times 1 is equal to 0 times negative 4. So 0 is equal to 0. So that looks good. Question C is x divided by 2 plus 1 equals 6. So we can subtract 1 from both sides first to get 5. And then since x is being divided by 2, we can undo that by multiplying by 2 and we get x equals 10. And once again, if we plug 10 back in for x to see if it is equivalent, we get 5 plus 1 is equal to 6, 6 is equal to 6. So yes, it does check. Alright, and then on the last one here, I'm going to move back up here. And D, we have 4t minus 2 plus t squared is equal to 6 plus t squared. So the first thing is we want to cancel out the t squared, so we're going to subtract t squared from both sides. That'll leave us with 4t minus 2 on the left and 6 on the right. We can add 2 to both sides, get 4t equals 8, divide by 4, and we get t equals 2. And once again, if we plug that back into the original, 4 times 2 minus 2 plus 2 squared should be equal to 6 plus 2 squared. So let's see what we get. 8 minus 2 plus 4. 6 plus 4. 8 minus 2 is 4. 4 plus 4. Or sorry, 8 minus 2 is not 4. 8 minus 2 is 6. 6 plus 4 is 10. And then 6 plus 4 is 10. So it is the same. So here are each of the answers to A, B, C, and D. Question 38. The fabulous footballer scored an incredible 55 points at last night's game. Interestingly, the number of field goals was one more than twice the number of touchdowns. The fabulous footballers earned 7 points for each touchdown and 3 points for each field goal. This is a multiple choice question. Which system of equations below best represents this situation? Explain your reasoning, assuming that T represents the number of touchdowns and F represents the number of field goals. So they're letting T represent the number of touchdowns and F represent the number of field goals. So they've already written the let statements, and we just need to figure out which one of the four systems below represents the scenario. So once again, the fabulous footballer scored an incredible 55 points last night. So 55 total points. Also, the number of field goals was one more than twice the number of touchdowns. So if 55 points were scored last night, then touchdowns were 7. So 7T for the total points there, and field goals were 3. So 3F. So we should have something about 7T plus 3F equaling a total of 55. So that looks like that happens here, here. That's a 3T and a 3T. So those two would be out. And then the second part where it says the number of field goals is equal to one more than twice the number of touchdowns. So twice the number of touchdowns and then one more than. So 2T plus 1 or 1 plus 2T. And that's F equals. So that happens here, not written the same way there. So it looks like number 2 would be the one that would be our system. B says solve the system after we select, which we did, and determine how many touchdowns and field goals. So now we need to solve this. So F is equal to 2T plus 1. And we're going to substitute that into our second equation. So F is equivalent to 2T plus 1. So that's what we're going to replace the F with. Now we have one equation and one variable. So we will go ahead and solve. Subtract the 3. So 13T equals 52. Divide by 13. 52 divided by 13 is 4. So it looks like we have 4 touchdowns. And then we can take T equals 4. And since field goals were one more than twice the number of touchdowns, it looks like we should have 9 field goals. So let's make sure we answer the question. There will be 9 field goals. And 4 touchdowns. Question 39. Yesterday, Micah was given some information and was asked to find a linear equation. But last night, her cat destroyed most of the information. Below is all she has left. Complete the table and graph the line that represents Micah's rule. So it looks like what we're given a single point and from the table, and then it looks like we also have another point from the graph. So we could fill out that, which would be negative 3, 3. From there, we could go and find the equation and everything, I guess, because we have 2 points. We could find the slope. We see that the x is changing by 1, and it continues to do that. The y, knowing these 2 points, goes down by 2, so we could continue that pattern. And as we continue it, I think that gives us everything that we need to complete the table and to graph the line. So negative 2, positive 1. A little small of a graph here, but do the best we can. Negative 1, negative 1. 0, negative 3. 1, negative 5. We can just continue this to negative 7 and 3, negative 9. And then we can graph that the best we can there. And so part A is done. We completed the table and graphed the line. Micah thinks the equation for this graph could be 2x plus y equals negative 3. Is she correct? Explain why or why not. If not, find your own algebraic rule to match the graph and the table. Well, we do see that the change in your y's is negative 2 as x goes up by 1. So the slope should be negative 2. And we also see that the y-intercept is 0, negative 3. This equation is not written in slope-intercept form, so why don't we take it and write it in slope-intercept form and see if she is correct. Let's see, solve for y, so we just need to subtract 2x, and we get y equals negative 2x minus 3, which means the rate of change or slope is negative 2, with a y-intercept of 0, negative 3, so it does look like she is correct. So let's make sure we thinks the equation is correct. So is she correct? Yes, she's correct. Explain why or why not. And if not, find your own, but it is correct. So yes, she is correct because the slope is negative 2 and the y-intercept is 0, negative 3. Alright, question 40. Kevin and his little sister Katie are trying to solve the system of equations shown below. Kevin thinks the new equation should be 3 times the quantity 6x minus 1 plus 2y equals 43, while Katie thinks it should be 3x plus 2 times the quantity 6x minus 1 equals 43. Who is correct and why? Well, when we solve using substitution, these two things are equivalent. The y is equal to the 6x minus 1, so we should be able to replace the y with the 6x minus 1. So we should have 3x plus 2 times 6x minus 1 equals 43. So is that Kevin or Katie? Well, it looks like it's this one right here. And so that looks to be Katie. So Katie is correct. And since it says y, because the y should be replaced with 6x minus 1. Alright, and the last problem here, 41, simplify each of D, write your answers using scientific notation. So on part A, we have 5 to the 0, which is 1, times 2 to the negative 3, that would be 1 over 2 to the positive 3. So that looks like we will get an answer of 1 over 2 to the third, which is 1/8. B, we have a to the third divided by b to the -2, but since it's raised to the negative power, we can write the reciprocal, so that would go on top, times, let's see, we have a to the first, and so we can subtract 1 minus 4 would be -3. So I just took the a to the first divided by a to the fourth and subtracted the exponents. And now we need to multiply, so by multiplying we add a to the third times a to the -3 would be a to the 0. And then b to the second times b to the second would be b to the fourth. A to the 0 is 1, so therefore 1 times b to the fourth is b to the fourth. On part C, where we have two numbers that are being multiplied that are in scientific notation, so we want to take the first part, 2.3 times the 4.2, and that'll equal 9.66 times 10 to the, and then these get multiplied with the same base of 10, and so you add the exponents, which would be 10 to the -1. Now it does say leave our answers in scientific notation, so once we're done, it is in scientific notation, so we're not going to worry about the -1 as an exponent. On D, we have 3.5 times 10 to the third times itself. So once again, we'll take the 3.5 times the 3.5, and we get a value of 12.25 times 10 to the 6, because you're going to add your exponents. Now this one looks like it's in scientific notation also, but remember, in scientific notation, this number needs to be between 1 and 10. So that means we need to move the decimal point over to 1.225. And then once we do that, what happens to the exponent? Do we go up from 6 to 7, or do we go down from 6 to 5? And so it should be 10 to the 7th power. So 12 is a larger number than 10, so then we have to add 1 to the exponent. And so 1.225 times 10 to the 7th power is in correct scientific notation.